In what's called self-supervised learning, we do this kind of thing. And so what we're going to do is we're going to learn to build a representation of your data without needing any labels. So if I've got pictures of things, or if I have financial transactions, or if I have text, and this is exactly what large language models are doing, what I'm going to do is I'm going to take your data and I'm going to hide part of it. So I'm going to hide that little square of that image. Or I will take your network of financial transactions and I will hide a couple of edges. Like, right, I'll go, I'm not going to show you that that particular money transfer took place. Or in text, I'm going to give you a sentence and I'm going to block out one of the words. And what your goal is as a machine learning system is to learn to fill in the thing that I've hidden. And clearly, I don't need labels for that, right? I just need raw images, I need raw text, I need raw financial transaction graphs. And what I can do is I can hide it and I can just train up a system that goes, given what I see around it, I think I can fill that in. And so you can train a system to do that. And what that does is it learns the representation for you. So now, if you remember what was going on before with transfer learning, we would learn to solve a complete end-to-end problem in one domain and we would borrow the representation, right? In this case, what we do is we use your data on both sides of it. So we have data here, and we have this thing's called a pretext task, which is basically just, can you fill in stuff I've blocked out, right? I'm going to mask things. There are tons of ways of structuring these pretext tasks. The most common one is this idea of masking and filling in. So I'm just going to take all this unlabeled data that I've got. It's self-supervised because I don't need any labels. I'm just blocking things out. And it turns out that if I do that, I can learn a good representation, which is key, right? That's one of the lessons of kind of machine learning over the past 15 years, is the ability to learn these representations is incredibly useful. And then I switch over and go, okay, I'm going to use my little bit of labeled data. So I've used lots of unlabeled data to learn a good representation. I'm going to borrow the representation. And then I'm just going to do the same trick I've been doing all along, which is, oh, got a little bit of data. I can put a tiny little classifier here that's easy to train up, doesn't require much data, and boom, I'm good to go, right? I should say, to kind of connect this back to some of the stuff that I said at the very beginning, this is essentially, I've got a lot of prior knowledge. So just like you had a tremendous amount of prior knowledge about the world when you looked at that and went, giraffe, standing upright in a far setting, right? Basically, these pretext tasks force the system to learn a tremendous amount of knowledge about the world, whatever the world of your data is, that then makes it easy to solve a variety of other kinds of tasks.